Oh, welcome back to OpenShift Coffee Break. And today we have also Tero last minute. So I see the screen, in the preview, 4 of us, and then there are other 3 that that are us. I don't know why, but it looks cool. I don't know if we can fix this. Let me check. Better now? Not sure, but it looks still cool. I hope you can all see us, and welcome back to OpenShift Coffee Break. Today we're gonna talk with Tero, with Jaafar, and Alessandro, our special guest, about Single Node OpenShift. You see, Tero is already having his coffee shot. I hope you had yours.
Yeah, mine
welcome.
is
Yeah, Jaafar has yours. Alessandro, where is your coffee? Okay, that's the way, man. Right. Yeah, welcome back. Today, very hot topic because we're talking about single node OpenShift. And you know what? Tero said, because of the coffee. Tero say, no, I can't do it. And then he appeared. Yeah, Tero is magic. This is a live demo effect. Fantastic. So I'm very happy to have you all today because we're going to talk about single node OpenShift. Tero, this is something we were waiting a long time in OpenShift, right?
About 5 years.
5 years.
No. Yeah, and then we did a lot of hacks that having a single node running virtualization, running multi-node. So yeah, it is kind of, it's a good thing to finally have it, but I can understand that it is pretty hard to get properly working since the possible chicken and egg problem that there is, that you need something to install. Like in OpenShift 4, you use the Kubernetes to install Kubernetes. And when you have a single node, it's basically pretty hard because you have to use the single node to install that environment. But one question, it's November, good cause. I started 1st of November. I have this. Where is your mustache?
Where is?
November.
November, yeah. Oh, yeah. The mustaches, yeah. You know what?
I just shaved mine this morning. Yeah, maybe I missed that, so I have to. Yeah.
So for the next show, we make sure we will have some of the
next show we have. Yeah.
The hipster one. Yep. But Tero, it's not. You have always this look and feel.
Yeah. It gives the senior kind of look. Yeah, but about the single node, it is good to have it since there are a lot of use cases that it's just insane to run the minimum 3 node environment and still. But yeah, I hope we have a demo. I hope so.
Well, I also hope so. And actually, we have a demo. It's just a spoiler. Just let me remind hello, everyone, also in the chat. If you have any question, please write down in the chat in YouTube and Twitch. We will bring your question during the show. Before we start, I would like to introduce Alessandro. So, Alessandro, who are you? Why you are here? What do you want?
First of all, thank you. Thank you for making me be here. It's a real pleasure. We had a quick chats with Natale in the past. I'm Alessandro. I joined Red Hat in August, actually, as a solution architect. And I also worked on many side projects in the past, both related to Kubernetes and OpenShift, like an installer for and a provision that we worked also with my friend and colleague Valentino Berti in the past when I worked as an instructor, also for Red Hat when I was working for a partner. And yeah, I'm completely in love both with OpenShift and Kubernetes. So I'm very happy to see this single node happening finally. So as Tero was saying, so really happy to be here and I will enjoy this one.
Thank you for your introduction, Alessandro. And you know what? We already have Tero and Jaafar and Alessandro. We already have some question in the chat. So Lo Zampo Ignaro Contento, which is a nice name in Italian, is asking, is possible to downgrade a running cluster to a single node, or you need to set up a new one and migrate the workloads? So the question is, can we downgrade an existing cluster in edge availability to a single node?
I don't think so, because the requirements for the VIPs are a bit different in terms of the IP that you reserve. So I don't think it's something that is possible. But when we will speak about the architecture and the installation process, I will try to make that a bit clearer on how it works.
Okay, cool. Thanks. Yeah, this is an interesting. Thanks for the question, lo Zampognano Contento, which you know what means in Italian? It means the happy bagpiper. So, and we are going into Christmas, so there's this, you know, there are people playing during the street, so it's cool. Hello, Adrian. Hello, everyone. So, Jaafar, Tero, Alessandro, we're talking about single node OpenShift. Can we recap a little bit what is single node OpenShift?
Yeah, sure. So traditionally, I don't think we use slides in this OpenShift coffee break, but since we have a nice one, maybe I could use that. But for people who have been with OpenShift for some time, you probably have heard what we call the OpenShift all-in-one installation, which is basically it was when we were in OpenShift 3.x. All the services running into one single machine, into one Linux. So it was very convenient for many things. So for us, as solution architects, it was convenient for our demo environments. It was very easy to set up and very easy to run on our local machines. And at that time, containers were just starting, so there was not really that need for edge and such things. But since the last years, a lot of things happened in the Kubernetes ecosystem. We saw massive adoption across all industries. And one of the industries that is now really into containerizing the services is the telco industry, for instance, where we have the containerized networking functionalities, what we call NFV and such things. And basically, when you are trying to deploy those services on an OpenShift cluster, you had, I would say, the first pattern was you need a full-flavored OpenShift cluster with 3 control planes and at least 2 workers. So that was like the thing before. I believe in 4.7, we released a new pattern that was the compact cluster, which was the ability to have 3 nodes that play both the roles of masters and nodes. So it was already a way to, for example, address the regional data center or maybe some offices where you want to have less infrastructure to manage your OpenShift and Kubernetes workloads. And one of the big asks we had from customers was to be able to run all of that into a one node pattern. So for example, for Edge, where you want to have your workloads really close to your customers or to your local branches, etc. So engineering has worked on that. It was not easy because, as Tero mentioned, we have automated a lot of things in OpenShift installation. And one of them is what we call the bootstrapping process. The bootstrapping process is basically you use an ephemeral external machine that starts all the containerized services that configure your OpenShift cluster. So basically, you use containers to deploy containers. And when you are doing all of that inside the same VM, there are some weird things that can happen. You have the load balancers, you have some VIPs that are going to be hosted on the bootstrap when you are bootstrapping the cluster, and then they will be held on the masters, etc., or the workers. So it's a complex process, and hopefully or luckily, engineering have worked very hard on it, and they have been able to make that work on one instance where everything happens inside the same node. So you do what we call in-place bootstrapping, and then the node becomes a master slash worker. It's not really a worker, it's a master that is schedulable, basically. So that's, I would say, the single node cluster in a nutshell. So some people have already heard about code-ready containers. So code-ready containers is, I would say, the developer-friendly flavor of OpenShift, but it's not a full-fledged OpenShift instance, whereas the single node cluster is really one. You get all the features of a full OpenShift clusters with things like metering, etc., that you don't get with an OpenShift code-ready containers. It's upgradable. That's great news compared to the other, I would say, developer-friendly, I would say, platform or pattern. So yeah, so that's the I would say one of the biggest differences. So of course, because everything is running on one node, you don't have the HA. So for example, the etcd, when you are running a traditional cluster, you have 3 control planes with 3 etcd instances to be able to have the quorum and all of those etcd things. But now you have one single etcd running in the node, so you don't have HA, but of course you can't have HA within one machine anyway. So that's, I would say, one of the differences with a traditional OpenShift cluster.
Well, Jaafar, thanks for this explanation. I think you already answered one of the questions we had. What that was, are the single node cluster upgradable? I guess yes, you say during the talk. There are other 2 questions. Maybe we can help with Tero and Alessandro also to answer. So one is there a list of supported OS distribution for single node OpenShift? And for this, I guess it's only one, no? It's valid for the same concept for OpenShift. There's only one OS. Correct me if I'm wrong, which is RHEL CoreOS. And probably the question were more around, hey, where can I install on-prem or on virtualization with other OS? I think it goes in the case of OpenShift in general, right?
So I believe OpenShift SNO is supported on bare metal installations. That's my understanding. That's, I would say, the primary target is to have that on bare metal installs. Of course, it works also if you are deploying it on virtualized environments. So in my case, that's what I'm running. But I think in terms of support, it's aimed toward a bare metal deployment.
What about ARM or Power? So is it only x86 or any other architectures?
I think for the moment it's x86, but I have to check actually for the the supported platforms. Maybe if we look at the assisted installer, we can have a hint on what's supported.
Yeah, because the OCP you can run it on ARM also, so probably it's coming.
Yeah. So again, keep in mind that this is fairly new. The single node OpenShift has been available since OpenShift 4.9. So I think it was released 2 weeks ago or something like that. I don't know exactly when was the GA date for 4.9, but it was somewhere around mid October, I think, or something like that.
It was announced also at KubeCon, so it's pretty fresh. Kind of availability is together with 4.9.
Yeah.
So it's very fresh on October-ish, let's say.
Exactly, yeah. So we will have more hands-on experience with that as we move forward. But yeah, today it's something a bit fresh even for us, I would say. So anyway, I've been waiting for this for a long time because again, it's easier to have your own OpenShift environment running in an all-in-one pattern. So this is aimed toward production. So this is something that customers can use to have their real workloads running in production on one single OpenShift, contrary to OpenShift containers, which is just for development purposes. All right. So any more questions?
Actually, yes, Alessandro.
Yep.
Can you? Yeah.
Yep. There's another interesting question that is regarding the subscription model for Single Node OpenShift. There is Pognaro Contento. This is asking whether the subscription model will be the same as the classic OpenShift subscription. So how does it work?
Yeah, it basically uses the same entitlement as a traditional OpenShift. It's just that it uses less subscriptions.
But it's free because master nodes are free, so it's free.
Well, yeah, but only if you are hosting non-application workloads.
Okay. Thanks for the clarification.
And since you are running application workloads, then it's not free. All right. So
just, one comment about this slide that when would you run a remote worker and when you have a single node edge cluster? Because when I remember when remote workers came, those raised more questions than like answered questions because of the Kubernetes network is not simple thing. So is there really use cases anymore for remote workers now that there is single node edge servers?
So one big difference, I would say, is that if you are in a disconnected environment, you can run a single node OpenShift, whereas the remote worker will not work, because the remote worker, of course, needs the control, the communication back to the control plane and to the registry, etc. So the remote worker can be useful in some situations where you want to, for example, you have already a central cluster and you want to extend capabilities to remote locations. So you can pop up nodes and remove them, but you are still managing your cluster centrally. You have one cluster that you manage and you are adding and removing nodes. So in terms of management, say you have 100 facilities. If you deploy remote workers and they are compliant with like networking requirements and stuff like that, maybe it's easier to manage that than having 100 single node clusters. So that's in theory, but single node clusters can also be managed centrally through ACM, which is our advanced cluster management solution that runs on OpenShift. So you can also have like one single configuration for your SNOs that is replicated through your 100 SNO clusters. So basically, I would say that the biggest difference is this. One is compatible with disconnected sites, whereas the other one is not. And also the network bandwidth. The remote workers will need some proper networking to be reliable and to have a reliable connection with the control planes. Even if, of course, we have done a lot of improvement compared to a traditional deployment. But yeah, that's, I would say, the biggest differences. Maybe you guys see other ones, but that's the main ones I see.
Yeah, I think that was good. It explains the differences between the approaches.
Okay, cool. So yeah, so as I mentioned, the SNO can be installed with ACM. It can be installed with the OpenShift install command line. And there's a new feature that I like pretty much, which is the assisted installer, which is basically you go to console.redhat.com. So it's a SaaS-based, I would say, portal that Red Hat has created for the customers to be able to manage their subscriptions, to manage their OpenShift clusters. And they added support for single node cluster as a tech preview. And that's basically what I used actually to deploy my own instance. So if you want, guys, I can, if there are no more questions, I can walk you through the process of doing that. I'm not gonna do a full installation, but I can show you some some of the main steps and also explain some requirements in terms of prereqs, like what IP and DNS host names are required and such things.
Yeah, that's definitely very interesting. Go for it. We have a couple of questions in the chat. We'll try to answer also during the chat. I think one interesting while you switch to the demo. One of we had a question like, is this available on OKD? And yes, it's also available on OKD. I linked it in the chat. Another cool, good question is ARM architecture supported for single node OpenShift? Because I think at the end, the edge use case is going to be multi-arc. But I don't remember if ARM is still, I think it's in dev preview somewhere, but I'm not sure it's supportable for bare metal. I don't know if you have more info about it.
Not really. We will need to check back on that topic. But yeah, that's Tero already asked about it. There's definitely support for ARM on OpenShift. Like it's a clear target architecture. So for SNO, we need to check where.
Yeah, I have seen their support on AWS for ARM. So we need to check, a single node OpenShift bare metal. I think there's no support yet, but technologically speaking, all the container and all the binary are available. I think it's just not supported yet.
Yes. Yeah.
Another cool thing would be running single node OpenShift on mainframe, IBM Power.
Yeah, but the mainframe can host maybe thousands of SNOs.
Yeah.
So you will have a whole data center in there. Okay. So now we are looking at the console.redhat.com, which is, as I mentioned, the portal that our customers can use to manage their subscriptions, to manage their OpenShift clusters. So what I did here is I just went to console.redhat.com. I selected like the clusters part. And what I do now is I go to create cluster. So from here, you have different options, and each one will walk you through the steps that you need to do to install OpenShift. So you can see there are managed services where you can run the installation. If you want to install them on the cloud, you can run them on a data center. And that's the option that we are going to use. So I'm going to go to create cluster, okay? And then it asks you for like what are the details that you want for that installation. So we will say coffee break, and I would say coffee break.openshift.fr. So I happen to have that domain, so I can fool around a little bit with it. And the interesting thing here is that you can choose to have a single node installation. And what this installer does is it will basically generate an ISO image that you can then load on your, you can bootstrap on your machine or in your virtualized environment. And it will talk back to OpenShift, to the management service, and it will automatically configure the instance for you. So it's very, very nice to have that. So, okay, we will say, okay, we see that we have OpenShift 4.9. I go next. And as you can see here, you can generate a discovery ISO. So basically what it does, it generates all the bootstrapping information. And as you load this ISO image, it talks back and gets configured. So there are three important requirements, which are, if you are familiar with OpenShift 4, there are two endpoints that need to be configured in terms of DNS, which are, the first one is the API. So it's basically API dot something. So it's API dot cluster name dot domain, etc. And the second one is, so the API is the endpoint that you're going to use to talk to the Kubernetes and OpenShift API. And the second endpoint is the wildcard extension that is added to all the routes that we create. So it's star that, for example, apps.openshift.cluster name. So those two DNS endpoints needs to have fixed IPs that you reserve, that will be managed by the IP failover services on the installation itself. So you will have those floating IPs that are managed by the OpenShift single node. But you also need to redirect the traffic to you need to reserve a fixed IP address for the host. So this is the part that is a little bit different from the traditional installation of OpenShift. So here you have the API and the wildcard that are two floating IPs that you will get. And then you will have a fixed IP address that you reserve for the SNO, basically. So once you generate the discovery ISO, it tells you if you want to have a full image, meaning that it's going to be about 1 gig, or if you want a minimal image that will have, like, I think it's 100 megs or something like that. And once you start it, it's going to pull the information that it needs. So if you want to be able to troubleshoot and connect to your SNO, so same way as we do with OpenShift, you can upload your SSH key in here, and then it's going to be added to the SSH key store in your OpenShift SNO. So that's it. You generate the ISO, you boot it, you wait for me, it took about, I think, 45 minutes or no, a bit more, maybe 1 hour to have the process completed. And the good thing is that you have a nice visual UI on the progress. You see all the steps, you can access the logs. So it's very nice experience to do that this way. So basically what happens afterwards is you see that the node registers itself here, and then you see the progress in this UI. So fairly simple. I really liked the experience. And I have one here that was installed. So you can see the link in here. You can download your kubeconfig. You can check the basically the settings, etc. So very nice experience. I really liked it, and you can try also to see if it works or not. So any questions about this?
Well, this is very cool. I don't know, Tero, Alessandro, if you have a question about this assisted installer procedure from console.red.com. Tero, I don't know if you already have if you ever used that, or if you plan to use that with Single Node OpenShift for your workloads.
Don't know. Actually, don't know yet, but I have a few questions. So basically, the assisted installer cannot be installed in an air-gapped environment because it needs the connection to the console.
Yeah.
But then, can you? But if you do the full image, the 1 gig, then is that possible to run in air-gapped, or do you always need the connectivity to upstream console?
So if you are using the service like the assisted installer, I think even when you are running the full image, because that's the installation that I used, you still need to have the network connectivity to this endpoint. But if you are using the OpenShift command line, then you can do a disconnected install.
Yeah. Okay. But there was a support for proxy, so you can set up the connectivity with the proxy. Yeah.
Correct.
Yeah.
All right.
Other good thing that is coming from the installer is that sometimes one of the obstacles that were found by the customers and also people that just wanted to try it, it was that it was a bit complex, let me say, to just have everything up and running, to just try it and then destroy the cluster and then recreate the cluster. So having something that is, you pick it and you start moving on from scratch, it's a very great thing. So yeah, this was one of the things that I think that are more appealing about this kind of installer, and also download the kubeconfig and have everything in place starting from the beginning. It's very cool.
Yeah, so honestly, it was a great experience. So I didn't plan to walk you through the installation, but maybe we can do that in another session or something, but because it takes some time. But basically, it was never that easy, at least for me, to install an OpenShift cluster. Of course, we have a lot of ways to do that. You have the YAML files, you have the OpenShift install, you have the ACM. So all of that works perfectly fine, and we've done all of that before. But now all I did really was go to the assisted installer. So again, this is in tech preview, but it works for, it's going to be supported soon. So you generate the ISO, the image, the OS boots up, talks back to the cloud service, and then it gives you a pop-up asking for information, like what's the API VIP, what's the wildcard VIP, what's the fixed IP, etc. And once you enter that information, like it asks you, do you want to set up additional disks, etc. So once you enter that information in the portal, it sends back the configuration bootstrapping to the SNO, and the SNO reboots with that correct information and starts the install process. So very smooth, very nice and easy to do all of that. Okay, so enough talking about the installer. So here we are looking at the SNO. How can we make sure? So basically you go here, you see that it's one single node that has both roles, it's master and worker. But if you look at the cluster settings, you see that there are no dedicated workers. So it's one master that is schedulable. So it plays the role of a worker. And the nice thing here is you can see that it can be upgraded actually. So there's an upgrade that is available. I'm not gonna do it now because we don't know what can happen. Of course.
Live demo effects.
Yeah, we want to show you the thing working and not wait for the installation to happen in the background. So basically you have all the features that you have with the traditional OpenShift cluster. You can see here in the overview that you have the metering that is working. You can use storage classes, etc., etc. Of course, there's an indication here that there's no high availability because we are in an SNO pattern. But other than that, everything looks exactly the same as OpenShift. And since we are in OpenShift 4, you can see that some changes happened in the UI. So let's go to a fairly simple project from the developer perspective and see if everything is working. So this is not the one I had prepared. I think that was this one. So here I see I have two workloads that are deployed, one Node.js app and one Quarkus app. And basically all the services are working in there, okay? So the application is started. The other service, the Quarkus one, is started also. So let's try and create maybe a new project and see if everything works as we do with a traditional OpenShift project. So let's call it Coffee Break.
One question meanwhile, what are the storage options that you can use? Is it an local storage or NFS, or what are the choices?
So very good questions. So you can, so what I did in this is just, something for my home lab, and it's not something, to use in your production environment. So I did set up an NFS storage class using the NFS provisioner. And you can see that I have a storage class in here. But you can create other storage classes and use. So they are available. I don't know to what extent they are going to be adapted for an SNO, especially if you're running on bare metal. But probably the most suitable thing is if you go to the operator hub, there's the OpenShift local storage operator, okay? And this is probably the one that you could use if you wanted to have everything running in one single node. So basically, you need to have a free disk that is unpartitioned on your machine. And once you configure the local storage operator, you can use that unmounted disk as the local volume provisioner for your OpenShift cluster.
That's interesting in general for OpenShift, right? When you have some disk you want to touch, and it takes care. Moreover, this is not the case because it's single node, but if you have multiple nodes, this take care of the complexity of or the intelligence, to attach a volume only on certain node if there is read write only. So it's a cool feature.
Yeah. So of course, as you said, it works for a traditional OpenShift cluster. And in case of an SNO, so basically the question of the storage, it's always, there's no one single answer for that. So basically, you are already in a non-HA environment, right? So if you think that your data can be safely hosted on the SNO for some reason, you can do that. If you believe the data should be better stored elsewhere and have your SNO set up to access the data there, then go for that.
Okay. Yeah. Of course, you have to consider the type of workload that you should run in SNO.
And the criticality of your data. So if it's data that you can afford to lose and reload, then okay. If it's data like that is mission critical, then you don't fool around with that and risk losing your data if something goes wrong with your SNO, for instance.
Yeah, but if we take a use case, remote side, maybe using local storage for message buffering or
logging
like that.
Exactly. Okay, so basically that's it. So you can see you have a full OpenShift experience. You have the dashboards. Everything works exactly as with the traditional OpenShift cluster. Let's switch back to the developer perspective and maybe try to add quickly a sample. So the 4.9 perspective has changed a little bit. I needed to get used to it, but now I can find my way around it. But yeah, it's a nice improvement to the UI. So I'm just deploying a simple Node.js app. You can see that the build started. It's cloning the code from GitHub. And once it's done, it's going to be running in here. So very nice, very easy to set up. Very happy with it.
Pretty cool. And Jaafar, I wanted also to share my single node OpenShift, which is in this Intel NUC. Very cool. You know what?
Of
because
course.
I'm doing the Red Hat Hackfest.
Please go ahead.
Chat. Yeah, let me share in the chat the link. There is in this week the Red Hat Hackfest. If you are interested to join, it's happening now. So, but if you are interested to join the community about the Red Hat Hackfest, is using the single node OpenShift. And then Quarkus, a Quarkus software stack, so a Java software stack to implement server-side and client-side pollution data to be collected and analyzed. So I think this is a cool use case. So you can put, as Jaafar did, your single node OpenShift in your bare metal hardware. You can put on a Intel NUC. To come back to your question about the architecture, at the moment it's Intel based, but the support of other architecture is also coming. I really recommend you to go into that links, because there's the procedure also on how to install additional software on single node OpenShift. But I really enjoyed this demo, Jaafar, because it was visible how was easy to install it. And at the end, that is an OpenShift cluster, which is a master worker together. I don't know if we can go into the compute zone, and we can see that is a master worker. So it's a single node where all your app will run. this is the I think this is the cool thing. I have one question, to be honest. What are the hardware requirements? What is the minimum RAM that you have to have?
So the documentation says 8 cores, 32 gigs of RAM. So that's the minimum, because of course there are services that will be running, all together on the instance, the etcd, the API servers, the monitoring. So you need to make sure that you have enough room for those workloads and your applications. So depending again on the type of workloads that you are going to run, you will probably need to beef up that platform to have enough room. If you are going to run PHP microservices that take 50 megs of memory, you are probably fine with 32 gigs of RAM. If you are going to use more specialized workloads that need gigs of RAM for each pod, you probably need a little bit more than that. So for my instance, I had provisioned, I think, around 90 gigs of RAM for the instance. So that leaves enough room.
How much the cluster is currently consuming memory and CPU?
Let me check.
Because that's pretty vanilla. It doesn't have anything extra currently.
Yeah, exact. So so the cluster, but again, keep in mind that some services will stretch depending on how much memory you have available. So the more you have, the more they can take, right? Based on the limits and the like the default requests and limits that are set up. So currently, my cluster takes, I would say, about 10 gigs of RAM and about 3 cores. Out of the, I have 14 cores available. But if you deploy it on a lesser configuration, it will probably take less memory because the monitoring and the logging will take less than that.
And one other thing would be nice to learn that how long is the service break when you do an update on a single node?
Oh, so yeah, I can run the update and let you know how much it takes. I didn't want to run the update before on the session. But yeah, now I can hit the update button and see how long it's gonna take. So it's totally different from, I think I have one cluster that I upgraded since OpenShift 4.1 that I still have. So when you look at the upgrade history, it's like pages of updates. This one is gonna be fresh. So the other one, I know how long it takes. This one, it's gonna be a new thing for me. I guess somewhere around maybe 30 minutes. I don't know.
Yeah, because it has to update the API, etcd, and then Dastian, and then it has to download the new
container images.
Yeah, and CoreOS and boot a new. So it has to reboot.
Yes, correct.
I actually tried it in the last days, and it takes it's about 1 hour. It depends basically on mostly on the networking. So for downloading all the new images for the CoreOS, and also the CPU requirements are quite
CPU.
The CPU requirements are quite, let me say, strict, mostly for the bootstrapping phase, because one of the issues that you can run also when installing production and you are just too restricted on the CPUs is that the bootstrap process is not going to go well.
So actually I ran into that issue, to be fair, on my first install. I did not provision enough CPU. I really tried even maybe below that minimum requirement to see what would happen. And the bootstrap did not complete because there was not enough horsepower to download the images, bootstrap the services, and everything that needs to happen in the background. Because if you look at the container image, you have tens of container services that run in there. And yeah, just to show you that it's basically a full-fledged OpenShift cluster, let me try to connect to my OpenShift SNO. So do you see my screen?
Yep.
Can you increase a little bit the font? Yeah, thanks.
Better. So
I have glasses. I don't need it to be increased.
So you see the tens of processes that are containers that are already running in the cluster. So
but now you have a situation that you need a second SNO cluster with a load balancer that you during the updates you have something providing platform for the workload. So suddenly you have 3 of those, and then you can actually
So of course that's why they say there's no HA. Of course, you need to bear in mind that you don't have HA. If HA is important and you need continuity, then probably you need to go with the 3-node compact cluster pattern if you still want to minimize the infrastructure. That's probably the safer choice for that type of use cases.
This answered the question we had in the chat, Jaafar, because Lo Zampognaro Contento asked on edge scenario, what is the HA for single node OpenShift? Because he say, I prefer to have 2 nodes rather than 5. But if somebody can use the compact cluster, so 3, I think it's a right choice, right? Instead of having 2 single node OpenShift, 1 compact cluster of 3 master worker.
Yep.
Yeah, but there is also this that in some edge locations you might have 2 sections in your data center, so you might actually have better to choose 2 single node clusters, 1 in each room, than have all-in-one 3-node setup where you have 2 nodes in 1 room, which is then single point of failure. So you don't basically get all. Of course, you will have 2 clusters to maintain, but you will have the same fail tolerance than you would have with 2 data centers with 3-node cluster.
Yeah,
this is the constant debate between you need a quorum. What if you have 2 data centers?
Yeah, exactly. And if you can manage externally the load balancing stuff, I mean, if the load balancer is not installed on one of the machines, like if you don't require an additional machine, and if you have hardware that can dynamically switch the routing and stuff like that, then yeah, you can probably go with that type of scenario where during the upgrade you switch, you move the containers to the other cluster, or you have them as an active or active passive, depending on the architecture of the workloads. You redirect all traffic to the one that is not upgrading. You wait till it's finished, and then you do the other way around.
Tero, to your point, probably if you have 2 different clusters, then you need some kind of a load balancer operator, or when you can route the traffic transparently, or submariner. I don't know. This is a multi-cloud, let's say multi-cluster use case. What would you use?
It depends. I would, like Jaafar said, that it depends so much on workload. How is it just that you need to have it like SLA is 23 hours per day? You just need it to be there on office hours. It doesn't matter then what you run. But if you need to have it's in edge, it's taking a lot of traffic, doing something, and then sending it forward to main data center. It depends on how critical can it go down for 1 hour, or should it be HA, and how often you need to update it. Because the kind of mentality with OpenShift 4 is you always upgrade. But if you take LTS versions, do you actually have to upgrade that often? Can you run like years without upgrading? So it's compared to how critical the workload, what is the security requirements, SLO, SLA. So there is no, let's say there is no silver bullet, but I would say that this gives a good option to have an multi-cluster environment that you can have with 2 data centers, you can have an HA application workload, so that you can, with external edge load balancer, you can actually use 2 clusters and the environment is supported, because that's important thing also. But you have to think about it. You have 2 clusters, and you will still have that single cluster is not a fail tolerant. So compared to what data you store, and the clusters don't have like maybe shared storage, so they are isolated. So if request goes to SNO cluster 1, store something, the data is not in SNO cluster 2. So these are the considerations, but it's a good extra option how you set up your environment on the edge.
Yeah, and so just to keep in mind something that the goal of all of this is, I would say, to ease not only the proximity of your workloads to your other business related applications or data, but also to simplify multi-cluster management. So the fact that our OpenShift SNO is like a plain, full-fledged OpenShift cluster, it means that it works seamlessly with the ACM. And you can use ACM to do these kind of things. Like if you want to move workloads from one SNO to another one, you can use the same things as you do with ACM, like by tagging the target clusters and removing flags and labels and stuff like that. You can centrally manage the workloads from your ACM to your hundreds of SNO clusters, for instance. Say you have like 100 branches where you have an SNO running everywhere, and you have connectivity to a central ACM, or you have 2 SNOs per branch or whatever. You can manage all of that centrally from ACM, as you would do with a multi-worker OpenShift cluster.
This is kind of the use case that, because the Red Hat didn't have the proper edge use case earlier. The one solution would be just run RHEL and containers.
Yeah.
But this now, the RHEL is now open. The OpenShift is the new RHEL. I said way back.
Exactly.
So this is that you don't actually install RHEL, you install OpenShift, but you run, you get all the good things from Kubernetes, and you run containers, and it's still single node.
And actually, you remind me of a conversation that we had with one of my previous customers, but it was years ago. I think it was almost 3 years ago or something like that, where they wanted to have that use case. So they were in a manufacturing, plants, and they wanted to have that minimal footprint where their services are containerized. So basically, that's the choice that they went with. So they had a RHEL with containers running on it, and that's it. But of course, you didn't have the management capabilities of OpenShift, the UI, the metrics, and all of that. The developer experience that you can also, because remember that also if you are using an SNO, one of their use cases was that they wanted to, from their local plant, if they had an update that they needed to push to their applications, that they could have a local development environment where they can make changes on the fly, run their CI/CD, on the plant and update the application without being connected to the central facility. So OpenShift was a great use case for that, of course, but it was not a pattern that was possible with OpenShift 4. So now they can do that because they can have a fully fledged OpenShift with maybe code-ready workspaces, with pipelines, with whatever operators they want to run on that single node. But it's going to be one machine that hosts all those services.
Yeah. Oh, and you know what? we have I think Alessandro's fan. There's lots of people say "Grande Alessandro." Hello, everyone. Yeah. Alessandro. You know, I have to explain that Alessandro is very active in our OpenShift community in Telegram. We invited him because he does lots of things with on GitHub with OpenShift, lots of experiment. He did also on Single Node OpenShift. And Alessandro, any final thoughts about it?
Yeah, and yeah, I also have to thank Rodrigo for the precious gifts that he produced for installing OpenShift from the bash. And I just adapted this one to an Ansible playbook that is publicly available. And yeah, my final thoughts are that Single Node OpenShift is something that it will probably change how we're going to approach edge customers and the different scenarios that can require disconnected workloads or something that should be also local. So I'm really happy to see how this will evolve. And yeah, it's been very great to discuss this together today. So thank you again for this opportunity.
We are happy to have you today, and thanks everyone for joining today. We are at the end of this session, this coffee break, unfortunately, because it was super interesting with demos and talk. But we keep talking on OpenShift TV, Jaafar. That is true, because today we have additional show, and I put the link in the chat about our streaming calendar. Jaafar, are you this afternoon again on the stream?
I don't know.
Okay. There should be. If we look at the calendar, there should be the level up, and then if you go to the calendar, there are other sessions this afternoon. If you like to stay connected with us on OpenShift TV, and for our next appointment is actually not on the November 17th because there's an event in between. Let me share also the chat. We will be in KDC Italy, which is a Kubernetes event, and I will share in the chat. We will come back the OpenShift Coffee Break will come back on December the 1st with another show on our series. And in the while, I put in the chat the next session on OpenShift TV. Please keep in touch with us and subscribe to our OpenShift channel. Let me share also in the chat the link to be connected with us, to like the show, to stay in touch with us. And yes, I will really thank you, Jaafar, Tero, Alessandro, for joining. It was a pleasure. And see you soon. See you soon on OpenShift TV Coffee Break.
Thank you very much.
Wow.
Ciao.
Bye-bye.
Bye.